In this lesson, we will start our discussion on one of the most important concepts in object-oriented programming, known as class inheritance or subclasses. The idea of class inheritance is based on sharing one class attribute, both data and method, in another class. So this is a technique through which we can create a relationship between classes for better code reusability. So inheritance allows a class known as child class to inherit attributes from another class known as the parent class. So let's first describe a scenario where we can use the concept of class inheritance. One possible scenario is to use it for different type of employees in an organization. So let's consider the department class of a university and consider different employees of a department in university. Previously we have created student, subject, instructor and department class and have links between those, but for this example you don't need to consider those cases and we will just focus on employees of a department. So even if you don't know what we have created in previous lessons, you can continue with this lesson. In a department we can have instructors as shown here. The top box or the row specifies the name of the class, which is instructor. The middle box contains data attributes for the class, which are first name, last name, email, pay, designation and list of courses the instructor will be teaching. Then in third box, we have the methods inside the class, which are raise pay for raising the pay of the instructor and assign course to assign courses to him. This type of diagram to represent a class is known as UML diagram, which stands for Unified Modeling Language. Now in a department, we can have employees other than instructors. For example, admin staff for different administrative duties. It will have data attributes as shown in the second box as first name, last name, email, pay, name of the admin team. For example, there can be different administrative teams like examination team, dues team, financial team, etc. And then list of the tasks assigned to this admin staff. Then there can be methods for this class as shown in the last box as raise pay to raise the salary and assign tasks to assign tasks to the admin staff. Now to implement these two classes, we can follow the way we have been doing earlier and define two separate classes as instructor and admin staff. But if you see carefully, these data attributes in both classes are same. And likewise, this method is also same in both classes, performing the same job. So instead of defining the common attributes of the two classes separately, we can have another class named as employee having the common attributes of instructor and admin staff class. Then we don't need to define those common attributes in instructor and admin staff class, but of course we need to create a link between employee class and the other two classes using the concept of class inheritance. Class instructor will be inherited from class employee and class admin staff will also be inherited from class employee. We represent this graphically by an arrow from instructor and admin staff class directed to employee class. So with this approach, employee class is the parent class and instructor and admin staff classes are child classes of it. A parent class can have one or as many child classes as we need. A child class inherits all attributes and functionalities of its parent class, and it can have its own functionalities which are not present in the parent class. Before we start coding this concept, let's first see different terminologies used for class inheritance. For employee and instructor class, we say that instructor inherits from employee, or instructor is a child of employee, or employee is a parent of instructor. We also call it as instructor is a subclass of employee, or employee is a base class or superclass of instructor. Then we can also say that instructor subclass is employee, or instructor extends employee, or instructor derives from employee. We will mostly use child-parent terminology. Now let's see that in coding. Here we have the employee class. There is init method with fname, lname and pay as input arguments, and we are setting those inside the method. The attribute email is being set using fname and lname. Also there is a variable total employee equal to 0 on line number 3. And inside init method, it is incremented by 1 whenever an object is created to record total number of employees created. Then we have raise pay method which uses raise amount variable on line number 2 which is set to 1.1. So when multiplied by current pay, it will increase that by 10%. And finally we have repr method for proper representation of the object. Now let's create the instructor class. that should be inherited from employee class. For that, we write the name of the parent class inside the parentheses while defining the child class. Now just by doing so, instructor class becomes the child of employee class and it inherits all attributes from the employee class. To verify that, let's have the blank class to start with. Let's do the same for admin staff class. Now if we try to create an instructor, you can notice that we are getting IntelliSense help for the parameters of instructor as fname, lname and pay. Our instructor class is blank, but because it is inherited from the employee class, so interpreter is referring to the init method of employee class. Let's print the type of the created object. And it is an instructor class object. Now let's apply isInstance and check if the created object is instance of employee class. And the result is true. So I1 is instance of instructor class and also an instance of employee class. You should understand that there is a relation between child class and parent class. So an instructor is an instructor of course, but an instructor is an employee as well. And that makes a good sense as any instructor is an employee of the department. Let's see total employees attribute of the employee class. And it is 1 because we created one instructor. So even with just the pass statement inside instructor class, it inherits all of the attributes of the parent class. Let's just verify the raisepay method on instructor class object. And you can see that initially pay was 100,000 and after the method applied, it is raised by 10% as 110,000. Don't worry about the little difference as floating point arithmetics can have these limitations. You can find that detail in the link provided in the description. Having a parent and child class, it is also possible to create the object of parent class. And you will see that the created object is an instance of employee class but is not an instance of instructor class, because a child class object is an instance of parent class but not the vice versa. Now let's also create instance of admin staff class, which is also a child of employee class. If we check isInstance on this object for all three classes, you will see that it is not an instance of instructor class, because there is no is-a relation between two child classes of one parent class. And this is quite logical because an admin staff is an admin staff and is an employee, but an admin staff is not an instructor. So that's all from this lesson, where we just saw the basic relation between child and parent class. From next lesson, we'll explore more exciting feature of class inheritance.